Right, okay, so wibbly wobbly idiot vision, we're about to do some testing. Now what we've got here is rotary converter, super dangerous. You'll notice the exposed shaft. Even more super dangerous, you'll notice the open box. But plugged into the rotary converter in there is a great big fat cable. That great big fat cable comes over here, and it comes up here, and it goes through a device, and it goes to this, which is a motor starter. It's got a thermal run out switch on it set to 6.5 amps, which isn't very much for a motor of this size, but we're not running it under load. And from there, we go down there and we go all the way around all this cable that's on the floor, and we come back up here and we go into these horrible domino blocks, which are probably horribly out of focus, if I would imagine. Yeah, probably something like that. That looks better. Which are connected up to the motor. And the motor is set to run currently in its 380 volt setting, high speed. I've already tested the 380 volt low speed setting. That works. Now what I can see over here as well, I've got a block hanging from the wall. It's just there, and that will tell me the voltages on the 3 phases. That's plugged into the same supply, it's just a set of voltmeters. So I'll put you back in there and we'll see if this feels like starting up. So first of all, a bit of noise from the rotary converter. Okay, we've got 240 volts on all 3 phases. What's going to happen? Okay, high speed, still working. So we have vindicated the intervention on the inside of the motor, because I haven't actually broken anything. It's still working. This is good news. It's working just as well as it was before. Now, if you'll give me some time, I will rewire all this so that we are in 220 volts high speed. Right, all that crap is now rewired into delta, so we're now hopefully 220 volts low, still high speed, 220 volts high speed. So the converter might have a bit more trouble with this, but we'll see how it goes. Oh, it doesn't like that at all, does it? I don't think the converter likes that at all. Right, well, we're back to high voltage mode. All the low voltage stuff doesn't work, unfortunately. My rotary converter doesn't have enough power to kick it. So we're just going to have a quick look, see how much power we're drawing, and how much amperage we're drawing in high voltage mode, just to see for interest's sake. Okay, so it's pulling about 1 amp empty. Okay, which is about 1 amp per phase. What's the takeout from this? Well, takeout is that my rotary converter, which is homemade, obviously, doesn't have enough guts to be able to run this motor, which is not entirely surprising, I suppose. So Piglit is going to have a a variator, which is a shame. I wanted to get away without using one, but I don't think I'm going to be able to, and I can't afford to get a 380 volt 3-phase supply put in. Not that would work with the lathe anyway, because that has a 2-speed Darlander motor that only runs on 220. So what's the next takeout from it? It was a bit of an extra work to pull out all of these wires. Not much work, it was a bit of extra wire, and it would be a bit of extra wiring to put stuff back into place, but basically it was worth it to get rid of all the knackered wiring that was already there. And what else can we say? Bugger all, really. It's an interesting exercise. I've done it before. There you go, you've seen the steps that have happened. It's a shame that in testing I couldn't get it to run on 220, because making it run on 220 would have been a really good solution for me. But there you go. Catch you later, guys.